opportunity to recognize the individual contributions of innovators, scientists, and engineers as catalysts for growth. India celebrates that National Technology Day with great enthusiasm, honoring the remarkable achievements of the nation's scientists, engineers, and innovators. The government organizes events and talk that delve into the future of science and technology, providing a platform for discourse and inspiration. Every year, a new theme is announced to inspire the young minds to explore technology and learn from India's remarkable scientific achievements. The theme for 2024 is From Schools to Startups, Igniting Young Minds to Innovate. Now, let's continue with our program. Now, I would like to request Ms. Vasuki to read the profile of one of our esteemed resource person, Dr. Shrikant Madakar sir.
Thank you, Pooja. Distinguished guests, esteemed faculty members, and dear students, it's my privilege to introduce our first speaker for today, Dr. Shrikant Madakka. He is a highly motivated scientist with over a decade of experience in deposition systems, materials, and electronic device characterization. With a strong foundation in physics, he has demonstrated exceptional skills in project management, interdisciplinary collaboration, and leadership throughout his career. He earned his PhD in physics from the esteemed Indian Institute of Technology, Delhi, where he showcased his academic prowess. In his recent role as a postdoctoral research fellow at the Indian Institute of Science, he delved into the exploration of polymer and perovskite based thin film synaptic transistors, highlighting his expertise in pioneering research. Notably, he spearheaded the design of a low cost atomic layer deposition ALD system for hybrid semiconductor growth, underlining his innovative problem solving approach. His technical proficiency extends across various domains, including thin film, nanostructure deposition techniques such as ALD, TCVD, PVD, and spin coating. He is also adept in utilizing material characterization tools like Raman, PL spectrometry, SEM, TEM, and XPS, demonstrating his versatility in experimental methodologies. Recognized for his significant contributions, he has received prestigious awards such as National Postdoctoral Fellowship from the Department of Science and Technology, Government of India, and the Institute of Eminence postdoctoral fellowship from the Indian Institute of Science. Beyond his research endeavors, he has exhibited leadership qualities as the president of the Physics Society at IIT Delhi and as a dedicated teaching assistant where he shared his expertise in solid state physics and laboratory techniques with aspiring physicists. With an impressive track record of presenting his research globally and participating in numerous conferences and symposiums, Shrikant Madakka stands as a distinguished figure in the scientific community, continuously advancing the boundaries of knowledge and innovation. We welcome you, sir, and thank you for joining us today.
Thank you, Vasuki ma'am. Now, I would like to request Ms. Janvi Rao to read the profile of our another esteemed resource person, Mr. Shravan K.S.
Good afternoon, everybody. Thank you, Pooja. I would like to present the profile of Mr. Shravan sir. He is also professionally titled as Senior Software Engineer in the company Betflux Co. He has a 5 years of experience in software development, and he also has a specialization in project management, web application development, data analytics platforms, financial technology. He is a senior software engineer with a deep-rooted passion for crafting high-performance web application that serve a diverse range of industries. He has over 5 years of significant experience in tech industries, focusing on developing both visually appealing and functionally robust interfaces. One of his notable projects was leading the development of Sika, a mobile application designed to empower small businesses in rural India. This project was particularly rewarding as they successfully achieved over 60,000 downloads, providing a crucial platform for users to engage in digital transactions and access essential financial services. And also, Mr. Shravan is our alumni also of SSMRV College. We welcome you, sir.
Thank you. Thank you so much.
Thank you, Janvi. Next, we are honored to have with us our esteemed principal, ma'am, Dr. Geeta, ma'am, who brings with her 19 years of academic and 1 year of industry experience with qualifications including MA, MPhil, MBA, postgraduate program in data science and business analytics, and PhD. Her contributions extend beyond academy and with notable recognition, including Women Principal of the Year 2024 by Raj Square Charity Foundation. And right, I would like to invite our principal, Dr. Geeta ma'am, to address the audience.
Thank you, Professor Pooja. Good afternoon, everyone. I hope all of you are doing well. Welcome to our webinar on From Schools to Startups, Igniting Young Minds to Innovate, organized on the occasion of World Technology Day. On behalf of SSMRV College, I extend a very warm and hearty greetings to distinguished speakers, Dr. Shrikant and Mr. Shravan, HOD, the Department of BCA, Professor Shanti Krishna, event convener, Ms. Pooja Biswas, and members of the event organizing committee, special invitees, teaching and non-teaching staff members, and beloved students. A warm and hearty welcome to all of you. Today, as you all are aware, we have an exciting lineup of speakers who will share their insights on cutting edge topics. Dr. Shrikant will delve deep into the fascinating realm of neuromorphic computing, offering us a glimpse of how the future of cognitive technologies would be. Following that, we will have Mr. Shravan, who will enlighten us on web application development, a crucial skill in today's digital landscape. I'm delighted to see the participation of all of you and the faculty members in this webinar. And I'm sure this webinar will serve as a bridge between academia and industry, aiming to inspire innovation and creativity among young minds like you all. I encourage each one of you to actively engage, ask questions, explore, and explore all the exciting possibilities that technology holds for you all in future. And I also urge upon you all to make the most of this opportunity to learn and engage. Thank you all for being here and have an enriching experience going forward.
Thank you, ma'am, for your inspiring words. As we near at the end of our inaugural session, I would like to request our esteemed resource person, Dr. Shrikant Madakar sir, to deliver his speech. Thank you, ma'am, for your enlightening words. Now, I would like to request our esteemed resource person, Dr. Shrikant Madakar sir, to deliver his speech. Sir, I think your mic is off.
Yes, I think right now I'm audible. Am I right?
Yes, sir. Yes,
Yeah.
sir.
So should I share my screen or should I upload my PPT? How should I do? I mean, which is, let me check.
Sir, you can present your screen. As you are a co-host, you can present it, sir.
Okay, okay. Mhm. Just I'm just taking a moment. So I will see if it is. Sorry for the delay. It is, I'm trying to open my PPT, but it is, taking a bit more time than usual. So this may be due to the high-end images which I have used in my presentation. Ma'am, is my slide visible to all of you?
No,
No,
sir.
sir.
So, so I could open. So if I want to share my screen, what option should I need to pick it up? Can anybody please tell me?
So you have to click on the present now button, which is like an arrow mark.
Just a minute. Yes. So, ma'am, is it visible now?
No, sir. It's
No,
not.
sir.
Sorry. I'm very, very sorry for wasting most important time. So, can anybody see right now? I could share right now successfully.
Yes, sir. Now it
Yes,
is
sir.
visible.
Okay. Yes. Is my video is also visible?
Yes, sir. Yes, sir.
Yeah. Yeah. A very good afternoon and happy National Technology Day to all of you. I'm Dr. Srikant Madhaka, and now I'm going to present the topic entitled An Introduction to Neuromorphic Computing. This is the outline of my presentation. Firstly, I will talk briefly about my research journey. Next, I will give a brief introduction to neuromorphic computing and its interdisciplinarity, role of memory devices, synaptic function emulation, and implementation of neural networks. And finally, a recent work performed at Indian Institute of Science in my previous laboratory. And finally, acknowledgements. So coming to my research journey, I did my PhD at Indian Institute of Technology, Delhi. So where my topic is related to vacuum diode characteristics of advanced nanomaterials. So here, I mean, before getting into IIT Delhi, so I could qualify the most prestigious three important entrance exams, including GATE, CSR, and JEST. So I got two graduate level fellowships, and I could also got, 10 plus publications and two best poster awards. After completion of my PhD at IIT Delhi in 2019 November, so after a brief stint during the COVID time, I moved to Indian Institute of Science for my postdoctoral research, where I have worked on system design and neuromorphic computing. Here, for neuromorphic computing, I have used polymer and perovskite-based thin film transistors for both memory and computing applications. And we have also designed a tool for semiconductor science and technology, which is based on atomic layer deposition based infiltration system. Here, I could get two prestigious fellowships. One is from Indian Institute of Science, and another is from Department of Science and Technology, New Delhi. So now coming to the most emerging topic, that is neuromorphic computing. Of course, this is an interdisciplinary field where we talk about neuroscience, material science, computer science and engineering, and electronic engineering. Yeah, firstly, I will give a brief introduction to neuromorphic computing. We all know that we are in the era of, we are in a computer era where we are enjoying the most sophisticated technologies in terms of Internet of Things, artificial intelligence, advanced telecommunication technologies like 5G, 6G, and so on and so forth. But to access or to use these facilities without any problem, so it is most important to process the humongous data produced by or required to access these facilities. But there is a problem with the computational speed and the performance to access or to process this humongous data, to access these technologies. So there is another problem associated along with this data explosion because of these technologies, that is the Moore's law, which actually states the doubling of transistors for memory and processing doubles for every 2 years. So which was predicted some 60, 70 years back by the famous scientist Gordon Moore. So even this law is no more valid. Actually, which simply talks about the computational abilities of computers will be doubling for every 2 years. So after year 2000, so this Moore's law is applicability is slowly vanishing. So now, so what is the possibility of dealing with this humongous data? So as we know, the von Neumann computers or traditional computers face a bottleneck called the von Neumann bottleneck, which is related to the data processing. During the data processing, data has to move back and forth from central processing or graphic processing unit to the memory unit, because of which there is a great delay. Since there is humongous data to process related to these technologies, the conventional computing system is not going to be suitable to process this data. So what next? So in 1980s, probably I would say 1990s, there is a famous scientist called Carver Med at California Institute of Technology, simply called Caltech. So they started working on brain-inspired computational stuff. So which led to actually neuromorphic computing. If there are any questions in between also, people can, students or professors can ask. So the first seed towards neuromorphic computing was laid by Professor Carver Med at Caltech. So, so what is the, let's say, greatness or beauty of this neuromorphic computing? So we all know the most sophisticated and highly energy efficient computational tool in the world is human brain, and which contains as billions of neurons and even higher number of synapses, which we can equate them to transistors, which have been used for memory and processing over the years in the integrated chips in almost all computational stuff what we have been using over the years, like our mobiles or computers, supercomputers for that matter, processors, microprocessors in day-to-day life. So in the search of advanced computational tools, the scientists could come across this amazing, let's say, computational tool in the form of human brain. So they could draw the inspiration by doing both, by creating memory and processing at a single place. That means rather than in conventional computers where we see, just like what I have shown, both processing unit and memory unit both are separated. But whereas in the case of our human brain, this is co-located. That means wherever it processes the data, in the same place it can store the data. So by taking this principle from the human brain, the scientists across the globe started working on this neuromorphic computing. So this computing, I mean, this neuromorphic process is not sequential. It's a parallel. At a time, you can do, let us say, several works, just like we can listen and we can focus and we can see and we can dance together. This is possible because of our, brain's ability to control the organs, I mean, at a time, rather than in the sequential process, what our conventional computers does. So if I look into the neurobiology or neuroscience, so this figure shows the two neurons in between the. Is it? I mean, is it visible? My cursor movement is visible.
Yes, sir.
Yeah. So if I see there are two neurons. One is, of course, in bigger size. Other I have zoomed out. I mean, in another part. So if I see the contact between these two neurons is basically is called synaptic cleft or synapse simply. So so I can also show this. These all small endings of the axon are called synaptic terminals. Basically, here the process is electrochemical process where calcium ions move when any process triggers in the form of action potentials. For example, if I'm, let's say, keeping my, let's say, a foot on, let's say, sharp objects, so immediately it starts, the neuronal system starts passing signals in the form of action potential to the brain, and immediately brain suggests us what has to be done further. So here, so this process is completely parallel and energy efficient. Our brain uses 20 watt, and it fits exactly just in our head in very small space. If I compare the same with the supercomputers, what we have, the most sophisticated supercomputer, which is located in Chennai at Indian Mathematical Sciences, is quite big. It occupied, I mean, bigger and as entire building. So based on this important feature of the brain, so the scientists across the globe started working in this important area. Now I will move to other slides where I will talk the interdisciplinary nature of this field. See, here I have zoomed out this synaptic gap or cleft. So whenever there is an action potential starts from the presynaptic neuron, that is the first neuron. So it starts sending calcium ions based on the strength of, or the, let's say, strength of the problem or activity, so that these calcium ions would move from presynaptic neuron to the postsynaptic neuron. This process is relatively very slower than the what we see in the conventional computers. Even though it is very slower process, still it is highly energy efficient, and it follows the parallelism. So if I see in the conventional computers, we usually follow the binary system, whereas in the case of a neuromorphic computer or the neuromorphic chips, we use spiking, the principle of spiking of the neurons or artificial neurons. See, if I show you the neuromorphic computer here, if I see my input is in the form of spikes. Here spikes means it may be the voltage spike or voltage pulse or a charge carrier related stuff, or optical pulse, light pulse, or any change in the temperature. So based on our requirement, we can choose the different spikes. and my output is also in the form of spikes, the way we have seen in the neurons. It starts with in the form of potential action potential in the form of let's say Ca2 plus ions. Similarly, this is action potential in the sense this is also just like voltage pulse in the synapse. Similarly, in the neuromorphic computer also, both input and output are in the form of spikes or pulses. So here pulse may be either in the form of voltage or temperature or light. So there may be a doubt in your minds, so why to put up the light? So in the case of pattern recognition, let's say object identification, you actually need to decode the object, so which is in the different colors. So where in such a place, the optical pulse is going to play a major role. So as I've mentioned previously, so here these are the various features of the neuromorphic computer or neuromorphic chip, or what actually happens in the human brain. Let's say the both processing and memory happens collocatedly at the same place, and this process is completely parallel. And this is also the way we have seen in our day-to-day life. We can adapt easily rather than our conventional computers. They cannot adapt. You have to let's say give instructions so that accordingly it follows. And again, there are limitations. And this is I mean, this process is inherently scalable, just like one human bottleneck. Here there are no bottlenecks. But the thing is, this topic is very new and emerging. Still, it is I mean very safe to say, I mean, it is inherently scalable, but it takes time. Time to comment on the translational research of this particular area. And this is also event-driven computation, which means, for example, if I'm, as I mentioned earlier, if I'm keeping my feet on the sharp objects, it actually, my pain receptors present in the neural system starts giving signal to the neuronal system, which actually sends the action potential. So in this case, it only activates certain neurons present in the brain, not the entire brain, which means unlike in the case of conventional computers, here the rest of the brain, rest of the neuronal system is going to be idle so that it can save the energy. And this is also fault tolerance, as it can take its it's very early to say, but if the let's say this area gets matured with the time, it can be fault tolerant. So it can take its own decisions, just like humans. So now I'm coming to the interdisciplinary nature of this field. First of all, as we know, the conventional computers, if you want to make computers, first of all, you need certain materials, like in the form of silicon and germanium, various types. That means one should have to have the expertise in material science and engineering. And similarly, if you want to make memory devices like transistors, diodes, or memory cells, various stuff, one has to has expertise in electronic engineering. And similarly, if you want to talk about this, these both topics are same in the conventional computing as well. But when it comes to neuromorphic computing, we firstly take inspiration from neuroscience, what I have mentioned previously, what happens in between two neurons. Similarly, the most importantly, by using different computer architecture, you need to invest a great amount of time and research on computer science, because you need to come up with the most important, let us say, energy efficient algorithms in the name of neural networks. And the most important neural network which is being used from computer science side to process the data and to implement this neuromorphic phenomena in the hardware, which is spiking neural networks. But the principle remains same. So that means this field to get success, or to take this topic to the translational research level, so there should be expertise from 3 to 4 important fields which I have mentioned right now. So firstly, to process, after processing the data or to store the input data, you need memory. You need to have the humongous amount of memory, especially if you want to talk about artificial intelligence, so for example, chat GPT. So you need to store the humongous amount of data in the form of input so that it can, for training of this neural networks, it is easy. For that, you need different memory devices, that in the form of non-volatile and volatile memories for RAM and RAM and ROM. So applications purpose. So the most important discoveries after it happened in 2008 in the form of memristor-based devices, which are compatible with the CMOS technology, what we have been using in the conventional computers. So this is ideal, but it is yet to be yet to reach to the translational level. So the great research is underway across the globe, including in our group, in our previous group, I would say. So, and similarly, so what transistors have been used from last 50 to 60 years, both in terms of with and without light. That means in the presence of light and without light. Similarly, there are magnetic tunnel junctions. So what we have seen previously in solid state disks and all. Fine. So apart from that, so as we all know, if I want to talk about similarly the memory, these are all based on electronic memories, what we have seen till date. But what if I want to process the object related stuff, that in the form of pattern recognition. So we all know we process, especially we humans process 60 to 70% of information through our eyes. That means through vision. So that means neuromorphic vision is going to play a major role, especially in the neuromorphic computing itself. For that, what we need optoelectronic neuromorphic computing. So what opto means here, photo, electronic means what we have been talking about from the last 50 to 60 years. So that's why here I'm talking about neuromorphic vision. For that, you need optoelectronic memory devices, or simply I can say photoelectronic memories. So this research is also going at greater pace to support neuromorphic computing, so which is indirectly supporting the artificial intelligence revolution, what we are talking, in day-to-day life more often these days. So firstly, before training, the way we have seen in the case of chat GPT, firstly you have to train the neural networks. Even before that, how do you talk at the unit level? For example, I mentioned about millions and billions of neurons and trillions of synapses. That means here in the neuroscience, each synapse is called as a building block. Similarly, each transistor represents a building block in electronic memory. So in this case, firstly, I would like to talk about the synaptic functions required for training these neural networks. So they are, if we see in our case in day-to-day life, let's say we undergo, let's say, short-term memory, long-term memory, and we do forget. Let's say if I read something for once, I cannot remember it for longer. Similarly, if I read for multiple times, I can remember it for longer. In the ideal case I'm talking about. Similarly, if I stop reading a particular content, definitely I'm not going to remember that particular content for longer. So here, now I'm going to talk the similar stuff here. So like the various synaptic functions, one is STP, that is short-term plasticity. Another is long-term plasticity. Here, short-term plasticity may be short-term memory or short-term depression. Another is long-term plasticity. Here, in the case of long-term plasticity, it may be long-term memory or long-term depression. So here, depression and let's say learning, we can correlate with let's say reading and not reading or forgetting. So if I show you the figure B here in this slide, see, so there are a number of lines. If I see on, if you see on y-axis, this is excitatory post-synaptic current. What happens in the second neuron? So forget about the current, voltage, all this stuff. I will talk about in terms of time. For example, so somebody is reading for several times, just if you see the upper curve reading, so the strength of the synapse or the memory is going to be for longer. That we can see on the y-axis. So see, this is the number somewhere I can correlate with 20. But let us see, if I read it just for, let's say, a couple of times or 3 to 4 times, the memory, what I can see in terms of current on y-axis is very low. That means the signal strength is very low. That means memory is very low. Indirectly, I can say the performance of the computing device is very low. Similarly, if I see, if I talk about figure C, see, if I see this current on y-axis, some numbers on y-axis, for sake of simplicity, I'm talking in this manner. So here, let's say this is the capacity of the memory and processing units, which are co-located in a neuromorphic chip. So initially, its capacity is higher, memory is higher. So if I stop, if I stop giving training to it for longer, and at the same time, similarly, the way if we stop learning something or reading for longer some particular content, we start forgetting that particular content, which is indirectly called depression. So that means in computer science language or in electronic science language, we can simply say erasing the data. So you need to do exactly the opposite process. Similarly, coming to the last last figure, that is PPF, pair pulse facilitation. Here, for example, if I read some concept for the first time, and I will gain some knowledge. And if I read it second time, if I'm giving the same amount of time, so the first time I am going to gain or get the memory of A1 amount. If for the second time I'm going to get A2. That means whenever we read for the first time, we are not going to forget entirely. So there would be some residual amount of memory, in our brain. Similarly, same is the case happens with these computing systems. So this is also being exploited for training the neural networks. This is here I'm talking about a single particular neuron, not entire neural networks. So we can integrate the same concept for neural networks. So if we talk similar synaptic functions, let's say in terms of, let's say, time, that is spike time dependent processing. So this is also time dependent. So this talks about time related stuff. So that also matters, right? See, when we talk von Neumann architecture, when electronic data moves from memory unit to the processing unit, and then after processing, it is coming back to the memory unit. So there is a delay. So here also we can correlate this time related concept to this. So finally, now I'm coming from the fundamental units, let's say single neuron or single transistor or single electronic memory unit, to the neural networks. So we have been hearing different artificial neural networks. The conventional computers also, people have used various, let's say, convolutional neural networks or reinforcement related neural networks and various stuff. But for the neuromorphic computing stuff, the most important and used or exploited neural networks is spike time dependent neural networks. So here, if I tell you in this picture, the starting all this just like bar chart like stuff is giving inputs to different artificial neurons present in the tier 1. So all this, let's say, if I talk this column of this neurons as tier 1, the next one is tier 2, and the last one is tier 3. That means for the tier 1 artificial neurons, we are supplying the data for the training. So after processing of the tier 1, this data by the tier 1 neurons, the output goes to the tier 2 neurons as the input. So in this process, the data processing and memory is collocated up to some extent in the tier 1 artificial neurons. Similarly, same goes to the tier 2. And similarly, after processing data being processed and stored in the tier 2 artificial neurons, the output goes to the final, let us say, tier. This is in the form of output. Let's say if there are other tiers in between, let's say more tiers. So each let's say columns artificial neurons output becomes input to the next tier. Similarly, so this is being firstly trained, and what happens with this, just like what we do in chat gpt, if I want particular information, it gives information by processing on its own in the given input only, in the given input amount of data only. For example, in the first generation of ChatGPT, or let's say third generation ChatGPT 3, if I talk about, they have initially fed the data till 2021 January. That means if I want to know any information related to 2022 or 2023 related to ChatGPT 3, for example, it cannot provide. It says, sorry, I do not have any answer related to this. This is this hypothetical question. That means, but whatever the data we are supplying to this neural networks, it process, but within that it processes on its own, and it gives, let's say output. So where these are going to be useful, for example, in the modern warfare systems, if I am sending drones towards the enemy sites, what is going to happen? Definitely, if after feeding a lot of data, so it can correlate data internally, and it can extrapolate what might be the situation based on the opponent's actions. So it can take its decision rather than sending back that signal to the base station, to the army station. Similarly, what we see in moon rovers, in recent times, we have had the great success in space technology there also. So whenever this rover collecting any data on the moon's surface, it has to send that, let's say, imaging data to the ground, to the earth, and they process, and then they give the command. Based on that, it acts. What if we provide a lot of data so that it gets trained and it acts on its own, so that there won't be any delay? We no need to wait for any, let us say, for processing of data. So we can avoid the data, and at the same time we can process the data effectively, because the parallelism or parallel computing is going to be part of this computing. So there are several applications. This is possible in the modern medicine. We have seen nowadays robots are being kept for surgeries and all. If we once feed a lot of data, what has happened with the previous surgeries, maybe in terms of huge number of, let's say, patients' data, so that it can come up with, rather than we doing, it can do in a better way. And similarly, when we face the epidemics or pandemics, so in such cases also, the large data we can feed, and we can get the most important, let us say, output in the form of advice while giving the treatment to the patients. So which means this is also useful in the modern medicine. So so basically, my work is mostly related to physics, what I have done, or vacuum electronic devices, what I have done during my PhD. And when I came to Indian Institute of Science, I worked on electronic devices, but only during my bachelor's only I have had a few computer science courses like C, C++, SQL, and some basics of JavaScript. But I did not really work on computer-based systems, but really I tried my best to give a generic understanding of neuromorphic computing to BCS students. So actually I wanted to present something of related to my own work, but since based on the audience, I'm sure that many of you can even understand electronic devices and related memory and processing stuff. But based on students, I tried my best to come up with mostly computation related stuff. I know I'm still far away to talk about computer science and engineering, are talking about algorithms and robust algorithms, how they're being developed and given to this neural networks for the training and all. Yes, so I would say I have done a little amount of work during my postdoctoral work, after my PhD at Indian Institute of Science. So this is related to memory, not related to processing or anything related to computational ability. Here I used polymers as a very simple and flexible material. We all know polymers. So how we can use this polymer devices for transistors, for memories and neuromorphic computing. I tried and I did get little success, and we are very far away from on commenting anything related to neuromorphic computing, because I haven't done anything related to neuromorphic stuff. But yes, I'm fortunate enough to get 2 prestigious fellowships in this area. That is just I studied, I learned, and then I wrote proposals for the government and for these institutes. But if you see in these figures, firstly, I used purely electronic related stuff in all top 2 figures and the last figure. But if you see in the third figure, I talked about light as well. I investigated light related phenomena. This is for purely related for pattern recognition or object identification. Although it would be tough to, for students to correlate this thing to neuromorphic computing. But in simple sense, I will say, firstly, you need memory to feed the data so that you can train the system. So by using hardware and software, using neural networks. Most importantly, we use most important neural networks are being used for neuromorphic computing. SNM, spiking neural networks. So here, photo memories, electronic memories, photo memories, spintronic memories. There are various different memory devices are being investigated or researched nowadays. These are all for obviously neuromorphic computing. They are because they are useful for neuromorphic computing. So I'm rather than talking more, because this is also very new for me, because although I studied, but I did not really investigate anything related to experimentally or computationally in my work. So rather than talking in the air, I would like to take questions related to this topic. And so I will move to acknowledgements. I'll talk briefly. I would like to thank my advisor at IASC, Professor Aditya, for his guidance and support, and similarly my group members and Government of India, Department of Science and Technology. And last but not the least, and I would say more importantly, I would like to thank the organizing team at Department of Computer Applications at SSMRV College for giving me this opportunity to present. And I would like to mention the most important person here, Professor Jitendra Kumar, who was my past advisor during my bachelor's at Sri Srinivasa Degree College in Andhra Pradesh. Thank you very much, one and all, for listening to me. I know my, let us say, strength in this topic is not that great, but I tried my best. Thank you very much, one and all. I'm happy to take any further questions.
Sir, I have a question.
Yeah, please, ma'am.
Sir, I just wanted to know if you can identify schizophrenic disorder people and how it could help neuromorphic computing.
Yeah, exactly. So I cannot really talk about very in depth in that. See, if you talk about anything related to neuro disorders,
Yes.
in terms of neuroprosthetics or anything, even epilepsy. So I'm very fortunate to see day before yesterday night itself. So that Harvard University, they could able to take a small piece of let's say brain from epileptic, let's say epilepsy disordered person. They could image using electron microscope. What I have done during my bachelor's and during my PhD. So here there is a group at IASC. Professor Vinny Gautam is actually investigating. Once you get to know the neural disorders, why some people are facing problems in terms of memory, in terms of, let's say, retarding, in terms of particular functions, for example, paralysis and all. So all these things you can get to know once you get to know about the cognition. And the many things you do unknowingly. You got my point. For example, you cannot touch the heart plate. You are not going to touch the heart plate, right? So why? Because it is already stored in your memory for the years that without touching, if you touch it, it is going to create problem. So because it is a hot object. Similarly, many things are internally stored. Okay, so coming to the point. So firstly, we need to understand the brain related disorders first to talk anything, neuro disorders.
Okay. Thank you, sir.
So I know my answer was not very, perfect or straightforward, but yes, so I'm going around and answering. Okay, please, any other question, please?
So I have one question.
Please.
So that neuromorphic computing, like, is there any real life application, or like as of now it is just under the uh, research level?
See, for example, see, I would say this neuromorphic computing is not yet at the stage of translational research. That means we can scale up. But if you see the most recent Apple phone, or even if you see, let us say in your, whenever you go for shopping in, let's say, e-commerce sites, you, let's say you are clicking on object A, or looking for object A for, let's say, once or twice, automatically you are getting notified in your email, or next time whenever you visit. So it actually tells you that these are the recent visited items. You got my point? This is very partially, let's say, improved artificial intelligence. You got my point? We haven't yet achieved even 0.1% in terms of neuromorphic computing, but yet I can say in terms of artificial intelligence, by using this technology, there is a little improvement, but we cannot say. But I want to tell you one more thing. So this technology is not mature, and funding mostly comes from the government bodies across the globe. Very few companies like Intel, IBM, and there is one university called University of Manchester, and Harvard, Stanford, and one other. They developed few neuromorphic chips. The first neuromorphic chip, which is developed by IBM's True North and Intel's Lohi. So, but these are, let us say, very big. Let's these chips occupied very big area, not like our let's say human brain. Not,
Okay.
I mean, I would say this is not yet there. We are not yet there. This is very emerging, very new. This is not yet matured, but its impact is there in the society already. As I told you, whenever you search something, it tells you that last time you have visited, and this is your let's say interest. It tells you, let us say, even whenever you search something in Google, automatically you may be in a different web page or a different tab. It tells you that you have visited last time recently, or automatically those ads would appear in your screen. Am I right? Did you ever observe this thing?
Yes, sir.
Yeah, this is actually, you can correlate it to artificial intelligence. That is actually, I mean, it is, these are getting trained, and but at very minimal maturity level.
So is there any relation between that quantum computing with this?
Yes. So basically, if you look at let's say there is a Nobel Prize winner in physics. That professor is actually working on quantum neuromorphic computing. The moment you talk about quantum, since I'm from physics, or I would say electronic engineering background, I can tell you quantum a bit nicely. So quantum basically is, if you talk about these just materials, nanotechnology, you might have heard nanotechnology. See, in
Yes.
that, when you talk about nano level, that means 10 power minus 9, that means 1000 or 1/100th of your hair thickness. There are materials like carbon nanotubes, graphene, and various other materials. Using these techniques, they are actually exploiting certain stuff like quantum qubits, just like we talk about transistors, diodes here. So similarly, there are different other, let's say, fundamental units in quantum computing by using, let's say, superconducting quantum qubits, using these quantum materials. So yes, there is a overlap, but the thing is, the only difference here, when you only talk about neuromorphic computing, this is purely correlated with the human brain. But when you talk quantum materials, it's the material wise also, the material which you are using, which is in the 1/100th of your hair thickness. Remember, where quantum effects start, let us say, reflecting in the device. So this is also good. Why? Because if I'm using very thin materials, my device size is going to be reduced and reduced and reduced. You might have seen there are two ways in terms of memory. In 2012, we have used we used to have in our mobiles just 58 MB. Nowadays we have GBs in our phones, and that too expandable. Yes, and also the let us say our laptops, our let's say desktop, I mean overall the CPUs are very bulky. Some 10 years back, in every day, if you see with time, they are becoming thinner and thinner. This is possible using the thin quantum materials. But yet, we have not seen any, let's say, quantum or the neuromorphic quantum technology in the real world. I would say mature technology.
Thank you,
I
sir.
hope this answers your question.
Sure, sir. So participants, if you have some another questions, so you can ask the question, or you can also write the questions in the comment section.
Sir, I have one question.
Please.
I want to know the difference between convolution neural network and spike neural network. Where and
Basically,
all you can
basically,
use the spike.
really did not work on convolutional related stuff, but those are being mostly used in traditional computers, where you have your memory and processing units are separated. Really, I do not know how it works, but whereas in the case of where you, with my little understanding, I'm trying to answer your question, where your binary system works. That means either zeros or in ones. Whereas in the case of neuromorphic stuff, there is nothing called binary. It's analog. That means which is let us say if I talk about in zeros and ones, right? If I talk about zeros, let's say it's a binary system. In the case of analog system is applied for this neuromorphic computing. Here, there are no zeros and ones, but rather you can assume like 0, 0.1, 0.2, 0.3. That is purely based on the strength of the neuron or neuronal activity. I'm sorry I couldn't answer your question because I really do not know much about convolutional neural networks. But if there are two ways I can answer. The one is in terms of binary system, and another one is traditional computing. These two are not applicable for the spiking neural networks, which are being used in neuromorphic computing.
Okay, sir. Thank you, sir.
So, one more question. What are the recent research trends in this neuromorphic computing that
Yes,
can be
ma'am.
adapted into computer science?
Yeah, ma'am, if I talk about, let us say, in traditional computers, as I told you, the difference. One is, once the data is moving back and forth, that is going to create, let's say, a delay. There is a time delay and efficiency also, speed also delayed. There is a two-way problem, that is. Okay, so here, by using in-memory computing, because of this collocation of these two processing unit and memory unit in the same place, so there are, as I told you, IBM, the first let's say neuromorphic chip is IBM's True North. If I want to use energy scaling, our brain uses only 10 to 12 picojoules, sorry, femtojoules. Femto in the sense 10 power minus 15 joule. For example, if I move my eyelid for once, let us call it as a synaptic event or synaptic task. To do that, our brain needs to pass an instruction to our eyes through neural system. It takes, let us say, 15 femtojoules, 15 into 10 power minus 15 joules. Let us say, in the case of these bulky neuromorphic chips developed by IBM, Intel, and all, the lowest possible one they have reached was around 380 femtojoules. You can understand the difference. Here, the brain as an area is very less. Occupying the area usually it occupies is very less, but these computers are occupied in big rooms. But still, its processing capability and energy requirement is very high. You got my point. So
Yes.
research is ongoing, but as I told you, it's a very emerging.
So it is more hardware related or software?
No, by using spiking neural networks, you can use in the algorithms so that you can reduce the power consumption, and at the same time, if I have any hardware, there also I can use to implement this neural stuff. Sorry, neuromorphic computing stuff in the hardware. Also, we can use. So the spiking neural network stuff you can use both in the software and in the hardware itself. I have read that.
Okay, so is this in future, can it detect all the disorders and patterns and all?
Yes, actually, there is already research going on. Even currently, where I'm sitting, just 2 floors, so 1 floor, so 2 floors down, there is a group, research group, which is, in fact, I'm in 3rd floor in my building. So in the same floor itself, there is a neuroelectronics laboratory.
Okay.
I would say, yes, this is going to be a reality very soon, but definitely it is not yet matured. That's what I say. But there is a group you can search, maybe right after this talk or maybe in your free time. Professor Vinny Gautam. She is an assistant professor. She has vast experience in this particular area. She is working on electronic devices at the same time, neurobiology, neuroprosthetics.
Okay. Okay, sir. Thank you, sir. Thank you so much.
Yeah,
So I have another
yeah,
question.
Please.
Whenever you have shown that neural network architecture, you told that tier 1, tier 2, and tier 3, all they are connected. So my question is, whenever
Right.
you are going to implement all these things in real life, the tier 1, tier 2, tier 3, I mean, it's implemented by computers only. I mean, computers are interconnected with each other.
Right. So I'll tell you. So if I were to go back, for example, see here in this slide, I have shown, for example, single neuron, right? Single neuron. Simply think that. So here I have shown 2 neurons. Just come to the brain. So all these bright spots, what you are seeing, these are the where in the brain. All you can you see small and bright spots? These are all synapses. Similarly, so in the somewhere I have used, yes, if you see in the electronic engineering here, the option where I am showing electronic engineering, next to that I am showing the IC, integrated chip. So in terms of these chips, if I keep these many chips together, in each chip you have maybe multiple or maybe thousands or hundreds of transistors. Each transistor works as a one building block. Let us assume that if this transistor works as a neuromorphic transistor rather than simply memory, just a conventional transistor, is a neuromorphic transistor where you can see both memory and computing. As I have shown, let's say in this figure, for example, figure B. Can you see here? I'm giving the particular transistor the training. I'm giving training by applying the voltage, by applying the light pulse or voltage pulse. So it is learning. There is a memory effect. So this is finally learning. This learning is what basically inspired from the neurons, what I have shown in the figure A. If I keep such stuff together, let's say thousands and maybe let's say millions, billions, I'll come to, let us say, if you see here, I have in our human brain, I have mentioned 86 billion neurons. If I say IBM, so True North, they are also using, let's say, billions of, exactly that number I don't remember. They're using lakhs and lakhs of transistors as, let us say, memory units, memory and processing units for this neuromorphic computing. So which means, but the only problem is those neuromorphic chips are occupying, computers are occupying huge area, very bulky, power hungry, but they are in the direction of, let us say, brain functioning, the way it functions. But the problem is, it is just emerging, not yet there in the market. It takes time. Shall I tell you something? So the current CMOS technology, what is there in our computers, is very old technology. You don't believe silicon and germanium people were using some 30-40 years back. Still we are using that. Why? Because industry to set up something new, it takes years. Just like even in the pharma also, to invent a new molecule, it takes years, because firstly we need to go for trials, let us say mice and all, and then the bigger animals, matured animals, and then on human trials. So similarly here also, the industry to come up to take up this technology from the academic researchers, it is a long process, but we are not there, I would say. Since I am learning from many days, and I am also not really working on neuromorphic stuff, but I am part of one work. We submitted one of my friends' work where I have done a little part, so in a big journal. I mean, it takes time, I would say. Firstly, I talked about, if you clearly see, firstly I talked about a single neuron in the figure, and then I moved to neural networks. Here, each dot in the tier 1, each dot or each, let's say, circle or sphere represents an artificial neuron. Artificial neuron. All these circles represent artificial neurons, but the thing is, the different colors represent different tiers, and definitely their memory and capability would be different because they are in the circuitry level. If I read for the first time, maybe my memory may be different, and if I read second time, my memory would be definitely different. Similarly, in the tiers, the memory would be different. And again, this neurons fires in a stochastic fashion. It's not actually in a particular way. So this is actually useful for unsupervised learning. In computer science language, you might have taught people supervised learning. That means particular direction. If you ask to do some task in a particular way, so that is feed forward neural networks. There is a particular type of neural networks where you are actually directing the neural network to do particular task in a particular direction. So where probably I'm guessing feed forward neural networks are useful there. But here spiking is very random. So whenever you think of remembering something, it goes randomly in your brain. The neurons start firing in different directions. After, let's say, 10 seconds, you say, yes, I remembered. I mean, it's a random process, I would say. This is good for unsupervised learning. And again, unsupervised learning, where it is going to be useful. Let us say driverless cars. That means autonomous learning, driverless cars. And in the moon rovers, whenever these tools are going to take decisions on their own, on its own, then definitely no need to send the data back to the, let us say, host or the operator. I think I'm trying to, had I taken the longer than the usual time for which I have been allotted a time I'm talking?
Yes, sir, we'll end with this question.
No problem. Please do ask if you have questions. So because I'm also learning. It's not that I know a lot. In fact, I published, I think, 10 plus publications, but in this area, I have just submitted one paper. I'm part of, I contributed a very little. So I'm also learning. I would expect, if there are no questions, I would expect a question from my advisor, past advisor, Professor Jitendra, if he's around. Thank you. I would love to say a question from him.
Can you hear me, Srikant?
Yes, sir. Yes, sir. Yes, sir. I can hear you.
Yeah. Of course, the knowledge should be very high in order to put the questions to you. You are doing a great research, and equal knowledge should be there. So, but even then, I can say that a boy who was there in a small village, traveling in a bus, coming to the college when he was in graduation, and now he has reached to IIT, completed a PhD in IIT Delhi, post PhD in IASC. Not a very small task. It's really very great task. I'm very happy that as a student of me, you have done this. I'm really proud of you, Srikant, and really do well in the coming days. And I think your dream going to NASA, surely it is going to fulfill. Thank you.
So thank you very much, and I must thank my parents and teachers. Especially, I started computer science, that's at bachelor's level. That too under the teachings of the majors are you only. The reason being, you had taught us a major portion during that time. In fact, I learned proper computer science a bit, at least initially. C++ I started with you only. Thank you very much, sir, for the invitation and for your kind words and wishes. Thank you very much.
Thank you, sir.
So,
yeah,
one question is there, and one student, she asked
please.
that does the neuromorphic computing even work with the smell and taste recognition?
Could you please repeat, ma'am, that question? Please?
Yeah, sure. Does the neuromorphic computing even work for smell and taste recognition?
Smell, right? Smell, SMEL,
smell.
right?
Yes, smell.
But see, again, it would be very tough to say. But again, I'll tell you how this is going to work. You all people might have heard about sensors. Am I right?
Yes, yes, sir.
Sensors. And if I go a bit deeper into it, so gas sensors, biosensors, so wherever you are going to, biometric, what it is doing actually, what it does, it is actually recognizing something is there. So if I call it as a biosensor, and in the where I am working here, I developed a tool. That tool is located in the gas sensors lab at Indian Institute of Science, where I'm currently in the same building. So easily, because that gas particle is sensed by the sensors, that sensed data is going to be converted into either binary or let us say, as I mentioned, analog signals. That analog signals would go to IoT. IoT would tell you on your phone that there is some smoke in your house. So please leave immediately. This is highly possible. And I mean, for her, his or her level, this is a very nice question, but this can be done. I think no need to go for even neuromorphic. With conventional computing itself, it can be done. Because see, we have gas sensors, right? Whenever there are toxic gases getting released from any company, we have sensors. The moment it is, let us say, it is sensing, that sensor is sensing, it sends information to siren, where we see the alarm, big alarm in the, let's say, within the premises, so that siren starts, acting, so that all people who are working in that particular area, they will leave. That is simply basically sensing related stuff. Yeah, it can be done. If I would tell you even in a simpler sense, we are using IoT in our phone. For example, heartbeat, pulsing, everything we are checking in our phone or in our smartwatch, which is indirectly related to that only. But the thing is, sensing is different. Whether it is bio or is sensing or mechanical. Let's say heartbeat is related to mechanical sensing. I think it can be done very easily. And thank you very much, a student, for asking this fantastic question. Because for that level, for their level, it is a nice question.
Thank you, sir, for sharing all this valuable information related to this modern technology. And I am sure that this kind of information will help our student for their higher studies. Thank you, sir.
Okay, thank you once again. Thank you very much, the entire team from SSRV, my teacher and principal ma'am, Dr. Geeta and Miss Pooja, for contacting me. I mean, time and again to schedule this talk. Thank you very much once again. Thank you, sir, for giving me this opportunity by contacting me, and in fact by remembering. Thank you very much once again.
If I say for 2 minutes, I was not I was not in contact with you. Suddenly, I was walking on the way. For 15 years, I was not in contact with him. I was walking on the way, and suddenly a student of me recognized and said, "Jitendra sir, I recognize you." Then suddenly he gave input about you, and then I felt that yes, he has done a very great task, and one day I have to invite to my college, and that is how you have come to my college. Thank you once again.
Sir, thank you very much, sir. Thank you very much for all the good words. Thank you and wishes. Thank you very much. Thank you for giving this opportunity again to all the people who worked tirelessly, I mean, behind the scenes. Thank you very much.
Thank you, sir.
Thank you.
Now, I would like to request our another esteemed resource person, Mr. Shravan K.S., to deliver his words. Sir?
Yeah, sure. Thank you. Good afternoon, everyone. I hope everyone is doing well.
Good afternoon, sir.
Yeah, am I audible?
Yes, sir.
Okay, great. Okay, cool. Thanks to Srikanth. It was a very good session. Always love to learn things about machine learning, neural networks, and all of that. It's a very insightful session. I hope everyone benefited from that, as well as me. And yeah, so a small intro about me before we start the session. I'm Shravan. I'm a senior software engineer. I'm working at a startup called Betaflux. So we make softwares for other technologies, other startups, companies. Uh, recent works like we are working on EV industries for river, ultraviolet, many companies like that, and also from finance, tech startups. Uh, we are working in a lot of areas. So yeah, I'm serving as a senior engineer there, and I also started my journey from where you all guys are sitting. Where you all started from SSMRV college, same BCA, right? I was part of I think 2015 or 16 batch, and had come a long way now. Jitendra sir was my teacher, Shanti Krishna ma'am was my HOD, uh, and yeah, it was a very good journey as a part of my curriculum. Uh, yeah, so I'll just get started. I'll just share my screen. Today I'm going to give a quick session about web development journey and how to start a career, build a career, what is the future, and all those things. Let's present it. Uh, I hope my screen is visible too.
Yes, sir.
Great. Okay. Cool. So what is web development, right? So this is the first question I think everyone will have, and I think everyone does know about what is this about. So it's just a part or process of building web applications, back end, front end, uh, things that live on the internet and interact with the users and everything. So development is a process of that, writing code, deploying all these things that live in the internet. And I think you all very well know about what this is. I'm not going to spend more time explaining about the what is web development, but yeah. So it's a way of development. It's a process of development, maintaining websites, web apps. Uh, Also, mobile apps comes under this, but it's a part of a different flow. Even though it is web development doesn't always mean developing websites, right? Although the term comes from web, meaning website or web browser, but it has more evolved than that. Earlier, we didn't have any back end, front end, and things like that. It was all just monolithic architecture. A monolithic architecture is more of an, writing it one way, and it has always been static, right? When the first internet was developed in, I think, in 1991, that's the way it was pursued. But after a lot of iterations, I think we are in web 3.0. We have done a lot of improvements. So web development doesn't have to always mean web application development, what you see in the website or e-commerce website. It also involves in your mobile application, how your mobile apps work, all those things, because all of them should be powered somewhere in the web, right? In the web server, all those backend and everything. So that's more about an insight about web development. So next I'll be jumping into what is full stack web development, right? So there are many ways, there are many parts or categories in website development or mobile development, whatever you choose. But one of the very high recognized jobs or careers is full stack development. Now full stack development involves in front end and back end both, being a single developer who is who has earned or who has the knowledge to develop both front end and back end and make the app ready or the website ready for the market. So this is what the full stack development means. So you will be part of front end architecture, designing, developing, doing a UI elements, interactive interfaces, all these things. That will be the front end part, and in the back end, it will be more about writing APIs, communication between the client and the browser, client and the web server, all these things. So this is the full stack development. That is the involvement around this. To just give you an overview of uh, how all this will play out uh, in the development cycle is, I think in the previous session we heard that neural networks, how they impact, how we can modify it, how we can try to come up with the smart ways of making life better, right? So all these are more about back end things, right? And whatever you might have developed models and whatever it might be, at the end of the day you should have some user interaction to it, right? Or else you can't access that information or gain information or get whatever you want, right? So we all know that the internet is network of computers, but it's just that, right? But how will you access it? Now you always need a web browser, you always need a Google, you always need something to access, that is a Google website, or Google search that you use. So that is actually the part, right? So Google is your front end, and it will be connected to a backend server, which will go and fetch some data. Now the data, fetching the data could be your neural network, maybe a model that might be running, or a website also, right? So you take some inputs, you process them, you query them into some database, and then get some input, get some result, and then show it to the user. So this is the full cycle. So it's more of like an, if I want to tell you, it's more like an uh, uh, college, right? So everyone needs to be part of it. There should be students, there should be teachers, there should be janitor. Everyone is part of that ecosystem. So it's just like that. How we do development, how the internet works, how the web application works, everything is just part of the whole thing. So full stack development comes in middle of these two things, which is front end and back end, which is you will be handling both of them. It doesn't mean the core development of back end, it does just mean the interactive layer, right? So you build your front end, maybe like let's say Google, for example. I think it's the best example to say. You type something, let's say you want to learn something or something, you just type something about on the Google. Now that what you're typing is just the front end layer, right? You'll have to make the UI very interactive to the user and all those things. Once you click enter, something happens there, right? All the data has been sent to backend. Now the backend is where you're doing some processing, minor processing. Now again, this is backend related, where you query the database or do some minor things. Now there is another part of this, which is the core development comes into play, where you could be taking that amount of data and doing some more analytics with it, right? You might be reaching out to a different server and all those things. That's really not comes under the full stack development. It's just about front end and back end, how the interaction happens, right? So there are many web applications, there are many frameworks to do this development. Like I think notably it's Node.js, PHP is also one of them. uh, I think Cake PHP. There are many frameworks that like that which help us to do. Um, that's all. That's the full stack development. What I wanted to tell, and what are the tech stack that we'll be using, right? As I just told you previously, there is front end. You can see there is React and Angular, and then Vue, which is all the front end framework. Which front end always means which live on your browser, right? It's as simple as that. Whenever you so and so.com, example.com, when you load it, the front end is the one thing that loads up first, right? So those are the front end application, Angular, Vue, and all those things. And then you have your back end, which could be Node.js, Django, Spring. You can also write PHP. Writes PHP, and then databases. You might use some databases to store your memory, data, and all those things. That could be a database like MySQL, Node.js, Postgres, and all those things. So these are the tech stacks that gets involved. And to throw some light around this, I would like to show more about what are the industry standards, right? And what is the highest, most used tech stack, which is very important when you're learning about when you're a new student who's starting to learn about web development. You always tend to go to a framework which is already popular, right? And which is already popular, where you can explore your options and more things. So this is a slide where I'm trying to tell you that the popular languages and frameworks, right? So the popular language as far as this year is always been JavaScript and HTML, CSS. You can see Python, SQL, and then the list goes on. And then the popular frameworks, Node.js, React, jQuery, Express, and Angular. So always try to pick the one that is always in demand, which is, obvious choice is React or Python. People always tend to use that in many of the projects, and it's not only about learning it. Out in the market also, a lot of companies use these technologies. PHP is one of those great frameworks which was very widely used. I think maybe 10-20 years back. Most of the websites that you see on the internet are built on PHP, mainly because how easy was it to use PHP, and how the scale of learning is very less, right? So that's why the PHP was very popular framework 10 years ago, and it's still continuing because a lot of websites are still built on PHP. It will take a lot of effort for them to migrate to newer technologies. I think one of the greatest examples of PHP is WordPress. I think you might have seen blogs that might be written across. People might be using blogging. All those website or web frameworks are coming from PHP. Now, the newer technologies that you see in the market, that are all built by JavaScript, Node.js, Flutter is one of the greatest new upcoming tech frameworks that is coming along. Uh, uh, that is, I think you might have used some of the Flutter apps in your mobile apps, like Cred is one of those example, right? Very intuitive UI and all those things. So very popular frameworks has always been Node.js. I highly recommend you guys to try Node.js or Python as the mainstream. I think Python is also uh, number one language in terms of learning artificial intelligence, ML, and all those models. So this could be like your starting ground if you're trying with Python. So Python is very strong language to learn, uh, very easy language to learn, and very well organized language, I would say, in terms of beginners, for beginners at least. So widely used in AI and all those things. So it's a very good language as well. Um, so yeah, so the one problem with web development that I see is, which I want to talk in the next slide, is skill enhancement, right? So every day, every week or so, you will see new frameworks coming into the play, new technologies to be learned. You have to be in a constant sense of learning new things. That's very much required in web development, because you're always being challenged to do something new that is not there in the market yet, right? Writing, creating an application which is never seen before, uh, trying to solve new problems. These are the very new things that you will have to learn, and be keep on learning yourself. So when you're into that technology, when you're into that subject, I think it will be more better for you to understand how it will work. It's more about keeping yourself updated. I think this applies to all the fields, but in web development is one of the crucial one, because the challenges you overcome is always different. So um, uh, just insight on that is, uh, a small insight on that is, we saw a lot of dip in a web application, usage of web application around 2016 to 2020, maybe around that time. Mainly because people were trying to, people were buying new phones, and they didn't wanted to use their apps, use their websites to search something. They always preferred mobile applications, right? So this was a trend that we saw. But more and more, once we saw the phase of AI coming into play, using of website has become more, uh, web apps or web application has become more uptrend now. It's a simple reason is, a lot of mobile applications haven't been developed on AI. They might be coming along, but a lot of them primarily people tend to choose doing it on web application, because it's just much more easier. So whatever the new technologies that might come into play will always be tried out on web application, right? You might have heard also a decentralization like cryptos, right? All these things, how does this work? All this work on a web uh, level of applications. The ground zero level for any web development testing or newer technology that comes is always on uh, websites and web application level. So that is where it holds an immense demand around the scale. So that is why it is very exciting and very important to keep always updated with the technologies. um, yeah. So and nextly, I want to just come to this phase of I think this will be something that is in a lot of talks right now. Will AI replace web development, right? You might have seen in many web development AI applications that you can just type in what you want and it will just give you the code of everything. It's like no code development. So it's a new term that they have been coined. It's called no code development, which is you don't have to code anything. You just have to do drag and drop or maybe tell AI to do your job. It's simplifying things. I would say not to worry about this because AI will just whatever you might have seen in the applications that you're seeing right now that is coming along is always on a very basic level. Maybe they might improve in some standards, but uh, when you are trying to build something which is very unique, you can't rely that on the AI just yet. Maybe at least for at least for 15 years or something. Just that phase will still be there. You will have to have your own development team to do that. So web development job is going nowhere, and the career is very strong. AI will help you to do your job more easier, trying to find more answers. And if it's just like people say, right, if you have a free time, you will try to learn and make things better. Uh, so if you're using AI in your job or in your work, it will just simplify your process and make your other things work better, right? So AI will not replace any jobs as of now on the web development, at least. I think so. It's a very good, strong career path to choose, and I would say it's a we can just go ahead and do that. Uh, whoever is interested is strongly recommended to try out developing, learning about the web development, and all those technologies. So I would say not to worry about these misconceptions. Uh, I would like so this concludes my slideshow, but I would like to interact more. And if you have any doubts on anything, you can just ask me about it. I wanted to keep the slides very short, because I knew everyone knew about the web development in a scale, but any Q&A sessions, any questions that you have that you're not able to get, I'll be happy to answer them. That's why I wanted to keep this short. So yeah, I think you can do that.
So I have one question.
Sure.
Can you little bit elaborate application that is built by you, Sikka?
Sure. Sika is an mobile application. This is actually it's developed by it is powered by a company called Moneybox. Moneybox is a nationwide leader. Sure. I'll come to that question. So Moneybox is a loan providers for the rural areas, right? For the tier 1 and tier 2 cities. So we wanted to build an application uh, that keeping in mind of these people, tier 1 and tier 2, mainly because, the way of they using the software is little more different than how we use in cities like tier 1 cities or uh, metro cities. So it is more about providing them loans like for agricultural loans, uh, cattle loans, and all those things, empowering their business and all those things. and we try to build a software around that. And also digital gold, you can buy some digital gold and all those things. So it's we have already seen, the company has already laid out more than 100 crores of loans using this application. So that's one of the helpful thing that has happened. It's very popular in northern states of India, mainly from Rajasthan, Uttar Pradesh, and all those areas. But they are soonly expanding to southern parts as well. Yeah, so that's the whole view on it. And the software is built. If I want to tell about the tech stack, the software is built on the mobile side. It is on Flutter. It's a new upcoming mobile application framework. We have the app in uh, Android and iOS. And the backend, it's all powered by Python Django. So all the web, handling of the error, API request and all those things, data handling, everything is done by that. We also have some data analysis that is going on. Slam, we have their own models of predicting few things, uh, uh, which is also written in Python. That is also there. So for example, how it works is, anybody can submit the loan, but this is an uh, they don't have much process for dispersing the loan. So all the information that is given by the user is put out to an ML engine, and it processes it and determines whether you're eligible or not. So all these things are also part of the Sika. So the whole application backend is based on Python, and front end is on Dart and Flutter. Yeah, I hope that clears out.
Sure, sir. So, two questions are there from two students.
Sure. Okay. Yeah. So, could you tell me how MVP product is built, monolithic front end and micro front end? Yeah. So actually, it's a good question. So MVP mainly. I would like to tell about monolithic approach, and how we have now a microservice approach. Monolithic approach is more about a little bit older technology, but it's still been used. It's not like it's not scalable, uh, uh, things like that. So monolithic is always means you're trying to put everything into one place, right? Your front end, back end, all your services are in just one central place. And the problem with this is, let's say if one thing goes out in your service, if let's say there is a SMS service, there's a lot of service involved. There's a SMS service, there's a email service, things like that in your application. Let's say due to some issue, SMS service went down, right? So there's a high probability chance that your entire application might go down because of this, if your code is not handled properly, right? So that is a problem of monolithic architecture. The scalability wise, nowadays, since we have a very good infrastructure in place, uh, monolithic or microservice or micro architecture, everything scales very well. There is no point of that. But it's all about convenience. How you want to architecture your web application or your application, that is more intended. It depends on the team. People still choose monolithic. I've seen people still do monolithic architecture and still go for microservice. So monolithic architecture is that, but microservice, what happens? Every service is your individual service alone. So let's say your application has to request for an OTP, it will call your SMS service. So instead of calling one same backend service, it will call different services. So even though if let's say OTP service is not working, it doesn't mean your entire architecture would go down, right? The users can still access many things. You can still go to your profile, you can still interact with the users, all these things, if all the other services are up, given that. So in terms of usability, it is more good to choose micro front end and micro architecture than monolithic. But some applications you can still use monolithic. If you ask me personally about which would I choose, I would always choose micro architectures, because it gives you a more convenient way of developing things, and keep everything distributed, right? That's one of the key features. I hope I've answered your question, and let me move on to next. What are the emerging trends in development that reshape the digital landscape and influence user interfaces? Yes. Um Emerging trends, I would say every day there would be new trend that will be coming along, but a very uh, standout trend, I would say, which is the front end technologies, is one of the new frameworks that is there is Flutter, right? So what they're trying to do is, it's developed by Google alone, and what they're trying to do is very very good idea, which is they're trying to keep one single code base to your entire development needs. Definitely. So you write in one language that is called Flutter and Dart. You can make websites, web applications, uh, mobile applications, Android and iOS, and even backend. You can also write backend with it. So it's like all in one framework to do everything. So it's like an emerging trend now. I've seen a lot of career opportunities for front end developer. It's a very new technology. The Dart is sort of resembles your C++ semantics, right? If you're familiar with your C++ and C syntax, I think Dart, learning Dart would be very easy and easy to pick up. Uh, and it will be very, I'm sure in the future, given that in a time scale of 1 or 2 years, it will be very trending. There are many technologies coming to alternatives to Flutter, but I think the Flutter has been a standard right now. Right. So we have one more, which is also pros and cons of using single full stack framework versus more diversified framework. Uh, it's, I think this question is more about uh, when you're trying to build an application, you will have to take this call, right? Again, this comes around your team, how your team will be there. If you are alone who is doing everything, then it is always good to pick a single language, a single framework to do everything, right? So it will be easy for you. But in a more distributed environments, like in your MNCs and things like that, you will tend to have uh, different types of people who have done different expertise in different languages. So they tend to pick up the languages they are more familiar with and try to do it. So in all, see, front end will always interact with backend uh, on an application layer, which is called JSON. I think you all might have heard about that. So writing it in any language doesn't make any difference. So it's all about learning it very well and being expertise in it. You can learn Node.js, you can learn PHP, you can learn Python also. All does the same job, but depends on what type of business you're trying to develop, and skills, and what are the skill set available to you, which is more important. I don't see any cons in them. Just what I told you is the same thing, but it's more about how you think while developing an application. Any more?
Yes. Can you hear Shravan?
Yes, sir. Yes, sir.
For the beginners who are developing project in web projects,
Hmm.
which tool will be the best one?
Uh, I would say tool would be to learn. The tool is if
Both
you're
back end and front end, both.
okay. A single place to learn everything is just learn JavaScript. So because if you learn JavaScript and as a core, you would also learn backend and front end, because on the front end no other program will work, no other programming language will work except JavaScript, right? So whatever you're saying here, web meet everything, is all designed with HTML, CSS, mainly JavaScript. So regardless of whatever you learn, JavaScript should be learned by everyone, right? It's at least in a basic level. uh, but if you learn more concepts on it, you can also familiarize backend with it. So giving it a try on Node.js, that is JavaScript, and React on the front end, uh, would help whoever is beginning. It will be very easy to learn, and a lot of uh, opportunities too.
Good, Shravan. Thank you. And one more question is,
Yeah.
after your BCA, directly you got recruited from the college or outside the college?
Okay, so after my college, I took some time to learn some new frameworks. So I think I spent around maybe 6 months learning Java. I had already knowledge of JavaScript, but I wanted to learn Python. So I learned Python, Django, and all those things. Made some freelancing projects. Found a few clients, made some projects for them, and then got myself familiarized with terminologies, all the tech world related things, and then applied to the job and got a placement. So that's how it went. But yeah.
Yeah, thank you, Shravan.
Sure, sir.
Thank you, sir.
You.
So, participants, is there any question from your side?
Shravan,
Yes.
there is a student, he asked one question, how to build a MVP product. So I think that question you have missed in the beginning.
Okay. Sorry, I think how to build. I think got it. Could you tell me how is an MVP product built? Okay, got it. So MVP is more about minimal viable product. It's a strategic software, creating like basic versions of test runs. Usually MVP, you can see um, uh, the products won't be out in the market, but it will be a framework type of. I can tell you it's like a prototype version, right? Uh, and how to build it is it's up to you. It's based on how what are the technology is known for you. But a basic way of doing it is if you want to prove a concept or something, you can always go to some designing softwares like Figma and things like that and get the basic things out. Make the flow overflow, how the user interaction works, and all those things for user understanding. Um, or else you can use some softwares to do this, like you know there are some softwares to help you to write. You can use there are some tools with JetBrains which do that. You can give your schema of your tables and all those things and try to uh, stitch them together, right? So basic minimum product will be built around that. But again, it's not really a market product, right? So it's up to you how to choose it. But I would strongly recommend you to give a try like Figma, things like that. You can always convert a Figma design into a real world application too. So transitioning from that prototype to a real world application is also seamless. So Figma is one of those tools to do that. Figma is there, and also there is a new software from Adobe, which is called, I think it's called Sketch, which is also there. So these are some products that you can use to build your own MVPs.
Any other question? Anyone want to ask?
Hello, Shravan.
Hi.
Yeah.
Yes.
Shravan, yes, you have delivered a very insightful and fantastic talk. Although I know very little in this particular area, but just I do not want to ask any question. But as you were saying something related to jobs, related to web development, but I would want to say one line.
Yeah.
So one of the Harvard professors is not against your statement. It's actually plus I'm adding. Yes, you can. So
Yeah.
one of the Harvard professors, his name is Professor Karim Lakhani. He stated something in his own words. I just want to read it out.
Yeah.
So AI is not going to replace humans. but humans with AI are going to replace humans without AI. So my point is, I definitely agree. You are somebody who is giving great assurance to, or let us say, fellow, let's say, maybe newcomers, and at the same time, if they learn AI, it would be good. I hope you are going to agree with me.
Yes, definitely, I agree.
ಇನ್ನೂರ 17 ಜನ ಇದ್ರಪ್ಪ.
I'm not saying against you, and I was very happy about the way you mentioned about job security in
Yes,
terms of
yes,
getting a job in web development. That was really fantastic from you. Why? Because such
yes.
words would actually can instill great confidence in the newcomers.
That is
Where,
right.
huh.
Yeah, yeah,
Yeah,
please.
nothing was against you, but I was just adding. Knowing something new is always good. That
Yes,
too, A would add something,
definitely.
yeah,
Yeah, so I think we can't ignore the fact that the AI is it's gonna come, and it's gonna dominate, but we have to more adapt to how it works, right? More you learn about it, the easier the job you can do in your daily activities. I think learning new things, right? Let's say I didn't know about neural network. Now I can now learn more things about neural network using AI like ChatGPT to learn more things very easily. That just simplifies more things, right? So this is how internet was also born. I would say making information free was the main goal, and AI is just another step to it. So it's not gonna steal away any very I would say very intuitive jobs that we do, right? It's not gonna do that, but it's gonna be a tool for it, definitely. And we have to embrace it more than fear it. That's what I want to tell.
exactly. Actually, awareness matters. Whether something new is going to come or not. I mean, irrespective of that, I
Right.
mean, awareness. Even let's say AI is going to give you three different answers for your, let us say, question,
Right.
even if it is entirely new. But you need to have that awareness, which is good for you, which fits the best for your requirement. To know that, obviously, you need to have very good knowledge. And
Right.
I just want to give a small analogy what I read some time back in 1960s, 70s, 80s. I exactly don't remember when scientific calculators came into the market. So most of the mathematics teachers across the globe, they started agitating, protesting against universities and all. But uh, literally they did not take away the jobs. Mathematics teachers we have, of course, right from the schooling to college. My point is, yes, as you have used the right word, embracing is the correct, and definitely giving respect to any new thing would add something to our kitty. Thank
Right.
you.
Definitely.
Fantastic to know about you. Thank you.
Is there any other question? Thank you, Mr. Shravan, for delivering such kind of very important informations, and I hope all this information will helpful our students for their future. Thank you, sir. And with that, we conclude the session of today's webinar, and I would like to request Mrs. Sudha to deliver the vote of thanks.
Good afternoon, all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I would like to thank all the honorable invited speakers, Dr. Shrikant and Mr. Shravan, who blessed us by sharing their ideas and knowledge. I, on behalf of the organizing committee, convey deep regards and hearty thanks to our Honorable Principal Dr. Geeta Ma'am for various help we received towards this webinar. I would like to thank our beloved head of the department, Mrs. Shanti Krishna Ma'am, for her constant help and guidance that radiated a source of energy within us. I'm also very much thankful to all event organizing committee members and the participants. Words are not enough to thank their constant guidance and support to shape the conference. Thanks to all of all of you for making this event successful.
Thank you, Sudha ma'am. And I want to say one thing, that after completing of this webinar, one feedback link will be shared for in that WhatsApp group. So participants, please fill that particular feedback form as soon as possible, and your e-certificate will also be provided in your email. So thank you everyone for joining and make that event successful.
Hello, Pooja ma'am.
Yes, sir.
I think we can take a snapshot with the speakers putting their video online, and then you can take a snapshot.
Sure, sir.
Video on, and they. Yes, thank you.
Thank you, sir.
Thank you everyone.
Thank you, everyone. Goodbye.
Thank you.
Participants, now you can leave that particular meeting.